And we're live. I'm back. I was gone last week and I missed you guys, but I am back in the saddle. So my name is Tim Van Milligan. This is RockSim Live, and thank you for participating today. I appreciate everybody being here. I wanted to thank Michelle for running the show last week. So Michelle did a great job. I actually caught some of it while I was in Texas live, while I was watching, while you were watching. So it was very neat to do that. We got a lot of people in the house. We got Alfred Indy, who says he is Joe from Michigan. We got Chris's Rocketry and More, Carlos from Marietta, Georgia, James from North Dakota, Josh Keating from Arvada, Colorado, and Andrew Simon from Ohio. And Carlos is telling me my audio and video is okay, which is great. I'm going old school today by using my Macintosh computer. I haven't used it in such a long time that I had to. I just wanted to make sure that I could still use it with the streaming software. So we got Rosa from Ottawa, Canada. Cool. Yeah. So. This is RockSim Live. This is where we answer your questions on RockSim, RockSim Pro, or the Launch Visualizer. What's this rocket doing here? This is, I'll show you this one. This is a new rocket that's coming out next week. So this is called the TTV. And it is a two-stage rocket. And it is for indirect staging. So indirect staging is having the electronics for the rocket in the stage, upper stage, and it's going to have an igniter that comes out the back, which you probably can't see because it's very small, that will go into the motor and then light it off at a specific time during the flight. So it's very cool. What's neat about it, it's a very small rocket. So we designed this because we came out with a product called the Simple Timer. And we wanted to test it ourselves, but we didn't want to fly a high power rocket because, you know, those motors get expensive and the kits are expensive. So I said, let's just build a small rocket so we can test fly it and just make sure that the timer is working and we know how to use it. And so this was our test rocket, and then we said, oh, let's make this a kit for our customers so that they can test their electronics too. So not only can you test timers for staging, you can also use it to test dual deploy electronics. So normally the eBay is up here at the front of the rocket, usually ahead of where the parachute comes out. But because this is for a timer, you need a wire to go to the igniter in the back, and it can't cross a gap. So the electronics bay is actually here in the back of the rocket, and you can just open it up like that, and you can see that this already has a timer installed on it. It's ready to go, and if all goes well, I'm going to launch it tomorrow. If all goes well. So this is the TTV, which stands for Timer Test Vehicle. Let me show you my screen. So this is the web page for the TTV. You can see a picture of it here. This will be available next Tuesday. So actually you can't get to this page unless you take that URL right here at the top. So, you know, it has a little window in it so you can see the blinking lights on your electronics to make sure that everything's working right. We call it a hammerhead design, where the bigger part of the rocket is up here at the top and the smaller part is at the bottom, kind of like a hammerhead. So that kind of shows you the transition in the middle. The motor mount is really unique, and this is kind of a picture of what the motor mount looks like because it's built into the electronics bay. Everything has to slide in together into the tube. So that's kind of what it looks like. And there's, your electronics, and there's a room here for a battery. So that's cool. Here's the parts, and we're kitting it up as we speak. So on Tuesday morning at 9 a.m. Mountain Time, this will be turned on the website, and you'll be able to purchase it if you so inclined. So yeah, I've been working on the web page today. Here's the simple timer for staging, and this is already on our website. So if you just type in the search bar right here, simple timer, this will pop up. And that's what the timer looks like. This is actually the TTV. This is our first, one of the first tests, and you can see this was an air start. So the second stage motor didn't ignite until the rocket was well up into the air, and you can see the booster motor. Its parachute hasn't come out yet. And so this was one of the early versions of the TTV. Taken off, and here's another smoke trail of what a timer will do for you. Air starting. It's just so cool. You get really cool smoke effects in the sky. And the timer also has a safety feature. If the rocket goes more than 45 degrees, it will inhibit the firing of the motor, but it will still fire off the ejection charge, so that will push the parachute out, so you'll still get your rocket back. So that's kind of what the simple timer does. But we're not here to talk about simple timers. We're here to talk about RockSim. I got another rocket though. Let me go back to my main screen so you can see this. This one's kind of hidden until I show you the main screen. This is where's my button here? All right, so this is another rocket that we started selling this week, and this is the Estes So Long. You can see it's pretty long. Let me get it in front of the other rocket, and it's also a two-stage, but this one does not use electronics. This one uses black powder motors, just the traditional Estes motors to stage the rocket, but it's a minimum diameter 29 millimeter. And I also hope to fly this one tomorrow, and depending on the winds, because this one's going to go really high. So that's that one. Let me put the stand back in. Okay, so let me see here on the comments, see what we got going on. We have Andrew Simon from Columbus, cool. Terry Wheelock, he wants to build a VTVL rocket. Vertical takeoff, vertical landing rocket. I wish I could, that would be really cool. We have Stirk from Pennsylvania. Alfred Indy says Terry Wheelock wants to launch a 3-stage and have different color smoke for each stage. We can do that in the launch visualizer. Different color smoke, it's set up for that. Alfred Indy says, I'm starting to think like Terry. Andrew Simon says, good luck with the TTV. Terry says, but I never think it takes too much thought. We have Johan here from the Netherlands. I was just watching a Japanese guy butcher a huge tuna. Was he in your backyard or on TV somewhere? Tuna steak. Tuna are underwater rockets, says Terry. Troy Ermit says, love the So Long. I've flown mine twice, E16 to an E16, and again on 2 E15s. Yeah, I worry about flying it on 2 E15s because it's going to go really high. And our RockSim simulations for the So Long show that it's really susceptible to weathercocking if you fly it as a 2-stage, because those big fins on the bottom. And those long burn Estes motors, we could maybe run a simulation and see what that looks like. Josh Keating says, Tim, I'm designing a level 1. I was wondering, should I take into account the shift in CG as the motor burns? Should I pick a motor and design around it, or vice versa? Okay, that's a good question, Josh. Okay, we'll get into that. So let me go to my screen and let's open up RockSim. That rocket motor that I had was leaking crud. RockSim, there you are. Okay, so I have the TTV right here. So let's go with a level 1 rocket. So he's asking, should I pick a motor and design around it, or vice versa? Our philosophy is design or pick your motors based on 2 things. One is the rocket design, and number 2 is the mission that you want to achieve. So, our level 1 rocket that we prefer is called the Zephyr. Yeah, let me see if I can open up a Zephyr. Okay, Zephyr rocket. Open. Save my changes here. Why not? Oh, it just crashed. We've seen that bug before. And in fact, a couple of weeks ago when I was here, I gave that one to the programmer, and he says he was able to replicate the bug, and then once you can replicate it, he can fix it. And so, and it happens when you have one design open and then you go to open a different one. So right now I don't have any designs open, so that was the didn't crash there. That was the warning from the last crash. All right, so Zephyr rocket open. Okay, so here's the Zephyr, and in 3D this is what it looks like. I think Michelle talked about this last week. People wanted to put how do you put these cutouts in the fins, and she talked about that last week. And if you weren't here for that, if you go to our website, and it's apogeerockets.com, and you scroll down to the RockSim training here, and you click on that. This gives you the archive, and here where did she talk about it? Sneak at upcoming kits, troubleshooting a design that doesn't leave it bad, how can you cancel putting a fin on the top of a fin. Oh, here it is, creating fins in RockSim with cutout sections. So that is how, if you want to learn how to do that, just watch that video here and go to 26 minutes and 4 seconds, and it'll show you how to do that. But anyway, this is our rocket that we'd like for level 1 because it's a big rocket. Let me show you what it looks like if you've never seen it before. Everybody's seen the Zephyr because it's pretty popular. So here's a picture of it, and open. So that's what it looks like when it's flying, and that's about how big it is, me holding it. So it's 4-inch diameter and 5 feet long, almost 5 feet long, 56 inches long, and so that's what we like. It's a simple rocket. It's very sturdy. It's really good. So now it's like, okay, I want to choose a motor for this rocket design. So now we have the rocket. So now is the mission. So what is our mission? Our mission is to do a level 1. But in a level 1, there are some criteria. One is you got to get it back. That's the most important criteria. Well, it's got to be successful, and you have to get it back. We assume it's going to be successful, but what can we do to increase the odds of getting the rocket back? And my philosophy is the lower it goes, the easier it is to get it back. You know, it's not going to drift away on you. So I want to fly a rocket motor that flies fairly low. So we built a feature into RockSim that allows you to pick motors. And so what it's going to do is it's going to run a whole bunch of simulations, and then we can sort those simulations by the peak altitude. And then we could say, okay, I want the one that's going to give me a pretty low altitude. So to do that, what you do is you go to prepare for launch, this button right here. I should probably make my cursor a little bit bigger here so you can see when I'm moving around. Privacy, accessibility, display, pointer size. There we go. Now we got a big cursor. All right, so you go here to prepare for launch. Click on that. Then come down here, and there's a button right in the middle called Recommend Motors, and just click on that. And these are the launch conditions that RockSim is going to use. And I would just leave these conditions alone. The only thing that I want to change is the launch guide length. So right now it's set at 4 feet. And this is going to launch off of a high power pad, which is an 8-foot rail. So I'm just going to grab this and slide it till I get to 8 feet. And then you're going to choose, you know, what motors you want. You can choose all manufacturers. You can, you know, limit it to just Aerotech motors. You can say just single-use motors or reloadable motors. I'm going to do all motors because if I start filtering it too much, there's not going to be a big list. And I want to show you how fast this goes. So once you set those conditions, just click on Use Recommended Conditions and click the button. And it tells me that it's running 59 simulations based on that criteria of Aerotech motors. And of those 59, it liked 57 of them. And so it's rerunning the simulations a second time. And the second time it goes through, what it's actually looking for is the optimal delay. So it's going to help you pick the motor and pick the delay that you need. So it's going pretty fast. We're at, you know, almost 40 of 57. So I'm going to take a sip of water here while we're doing that. And so this works really good for rockets that you're designing yourself as well. You know, even though I'm using a known kit, if I can treat this just as like I'm designing it myself. So it ran all the simulations, and there's a when it's done, it's going to take you to this tab on the end called Recommended Motors. And you'll see that most of them are recommended. And if I scroll through them, let's see if there's any that say not recommended. So there's one that's not recommended. So what I should never use in this rocket is an I-49 because it says that the liftoff speed on this one is unsafe. So that's what not recommended is. So now that we've got a list of motors, let's sort it by the altitude. And so to sort it, this is like a spreadsheet, and you can just click on the column header, and then it resorted the list. And from that list, you know, the lowest altitude is a G67, and that is recommended, but it's not a level 1 motor. A level 1 motor, you need an H or above. So we have an H73, it's the lowest altitude. We have an H283, you know, 1,700 feet. My particular favorite is the H100, and that's just a touch over 2,000 feet. So if you can live, any of these motors will work because they're recommended, except for, you know, that there's another one, an I-40. If they say recommended, I would be okay with flying them. And so that's how you would pick. And so I think your other question is, should I take into account the shift in CG as the motor is burning? Okay, so good question. So now we have a motor for the rocket. So now you're asking, let's look at the CG. So I'm going to go here to the 2D view, and it shows me the current CG, and I know that it doesn't have a motor in it because there's, well, one thing, it says shown without engines right here, but also on the image here, it doesn't show a motor in there. So I'm going to go up to the H100, highlight it, and then with my mouse, I'm going to right click on that row, and then I'm going to say load engines. And so when I load that engine, it put that motor in, and you can see the CG shifted back. Before it was up here, now it's back here. And so now we're at 3952 inches from the tip. So now when you're asking the question, should you take into account the CG as the motor burns? So you have to ask yourself this question: what happens to the CG of the rocket as the motor burns? It's going to move, and you're already assuming that. So which direction does it move? Does it move towards the tip of the nose cone, or does it move back towards the back end of the rocket? From a stability standpoint, we always want that center of gravity, which is this symbol right here, in front of the center of pressure. So if the center of gravity moves back behind the center of pressure, that's bad. We have to avoid that at all costs. But if the center of gravity moves forward, that's okay, because basically what it means is the rocket is getting more stable. It's getting more predictable. You know, I always equate stability with predictability, because if an unstable rocket, I can't predict where it's going to go. But a stable rocket, I can, and the more stable it is, the more I can predict where it's going to go. So the question is, does the CG move forward or backwards as the motor's burning? I'll give you a second to ponder that, and then I'll look at the comments here. Carlos K says, imagine a Comanche 3 with the streamer and the booster 1 and 2. How would we RockSim the streamers? Okay, so we'll answer that one next. So getting back to our first question, so what happens to the CG as this burns? So let's, we already ran that simulation. Let's go here to plot the graph, and under this, here's the thrust. We're going to plot thrust and the center of gravity. And let me clear out mass. And I want to plot the thrust because I want to see the engine burning. So as long as the engine's burning, I can see it. And then I want to know where the CG, how the CG is moving. And I want to have the graph go from to when we'll go to when apogee is reached. Okay, when the rocket reaches apogee, and then plot the graph. Okay, so here's our graph. The black line is the thrust of the motor, so that's the H100, and then here's burnout at around 2.34 seconds. Our center of gravity starts, here's the center of gravity, is the blue line. It starts at a point that is 39.5 something, 55, and then it drops to 38.25 or 0.3, 38.3 inches. So basically, if we look at the rocket here, the CG starts at 39 inches and then ends up at 38. So what it means is it's moving towards the nose cone. And that's good. As long as it's moving towards the nose cone, that's fine. So I'm okay with that. Most all rocket motors you will see this where the center of gravity moves forward. There is an exception, and that exception is for hybrid motors. A hybrid motor is a combination of a solid propellant and a gaseous oxidizer. And so that oxidizer is in a second tank. So imagine the tank is like way up here and it's filled with gaseous oxidizer, and usually it's laughing gas, nitrogen NO3. And so that tank is up here and the propellant grain is back here. And what happens is normally the back end is getting lighter, and when a hybrid motor burns, the propellant stick does get lighter, but so does the oxidizer tank. And so for a hybrid motor, the oxidizer, because it's in front of the center of gravity, it's getting lighter. So the front end is getting lighter, which means the center of gravity has to move forward when that oxidizer leaves the rocket. So on hybrid motors, which you probably will never fly in your life, those you have to be aware of. But for solid propellant motors like Aerotech motors, Estes motors, Cesaroni motors, always the back end is getting lighter and the CG is moving forward. Did I say that wrong before? When the oxidizer gets lighter, the CG moves back. I had that backwards. But you get the point. The center of gravity is going to move. Hybrid motors, you got to watch out. But black powder and composite motors, don't worry about. So you don't have to do anything special about watching the CG. As the worst case situation is at launch, when the rocket first leaves the launch pad. And that's called static stability, and that's the one that you have to worry about. And so right now our rocket is stable and it has a margin of 1.34, which means that the distance between the center of gravity and the center of pressure is 1.34 times the diameter. And we want to see that number at least 1, and we're at 1.34, so we're okay. So on this particular rocket, you don't have to worry about it. If you're designing your own rocket, make sure you check that location and look at your margin. Okay, so Carlos is a Comanche 3. So let's see if we got a Comanche 3. So I think I do. Comanche, I don't think I spelled it wrong. C-O-M-M. Here we go, Estes Comanche 3. Save my design? No. Okay, so here's a Comanche 3, and he's wondering how do we put streamers in the booster stage? And I'm looking at this rocket already, and I can see I've already put streamers in here. So the normal Comanche 3, let me give you a 3D, looks like this. Let me make it bigger so you can see it. It's a 3-stage rocket, and normally the boosters, they don't have streamers in them, and they just tumble recovery down to the ground. This is another rocket that can go really high, but to put a streamer in the booster stages in RockSim, you go to the rocket design components and you find the stage that you want to put the streamer in. So this is the sustainer stage up here. Here's the booster stage 2 and a booster stage 1. So booster 2 is the one in the middle. Booster stage 1 is back here. The naming is kind of weird, but you can tell if you look at the icon, this one shows a 3-stage rocket because it's colored all 3 stages. This one, just the upper 2 are colored, and then on the sustainer, only the top section is colored. So that tells me what part of the rocket I'm looking at. So if I wanted to put a streamer in this booster stage 2, I'd highlight it, show the parts, select the tube, and just drop a streamer in it. This one already has a streamer in it, but to make a streamer, what you would do is you'd select the tube, come up here to streamer, click on that button, and then it's going to bring up the streamer editor screen, which is this one right here. This streamer is already in the rocket, but you'll set your length and the width of the streamer, the thickness of the material, and I'll make that a little thicker. And it'll estimate the descent rate based on what you have there, and it'll give you the CD. And so basically that's what you do. So now I've added the streamer, click OK. And then to run your simulations, we have to load rocket motors. I find it, quick to go to the flight simulations that are currently listed, and then just find a motor set that you like. Here's a D12 to a C6 to a C6. You select it, and then right-click with your mouse and say load engines. And so it loaded that set of engines into the rocket. If you don't like them, now come up here to prepare for launch, and now you can start editing the motors. So if I didn't like a C6, I could select that stage, that motor, and then I could say, oh, let's use a C5 in there. But my only delays are 3 seconds. I can make it a custom delay. Let's make it C5 7 and use that. And so now I have my motors loaded, and then at that point it is setting up the flight events. So we have so this is one place where it can get kind of hard to tell. Well, it tells me here, booster stage 2, there's a streamer in it. Booster 1, remember, that was the middle one. It also has a streamer. And then the sustainer also has a streamer. So each of these streamers is going to deploy a maximum ejection delay. Man, there's extra streamers in here. These have parachutes. Let me turn those parachutes off. I didn't know there was parachutes in those. By doing no event, it'll just say ignore those deploying. So we're just going to have streamers coming down. Simulation controls, leave that alone. Starting state, it's on a 60-inch launch rod, aimed straight up. Launch conditions, I got a 6-mile-an-hour wind right here. I can tell that. And then I'll just see what it looks like in the flight profile. Okay, so here's the rocket sitting on the pad. And we can do launch, and we can see the rocket taking off. One streamer fell off. Second one lit. Okay, the second one came down here, and then our upper stage is up here. So it looked like I had a delay in there. But those are coming down with streamers on them. Now if you look at it, the upper stage shows the streamer, but the booster stages do not. That's because RockSim is the oldest of our software, and these are called, I forgot the name of them, sprites. And sprites are an old technology for displaying graphics, and the newest technology is, it's all vector based. So if you want to see what it looks like with the streamers coming out, let's save this design. I'm going to delete all these simulations. And then to delete them, highlight them, and then right click and select delete. It'll ask you if you want to delete them. I'm going to say yes. And then I'm going to save it. I'm going to save it to my desktop. So I'm going to do a save as. Estes Comanche 3. I want to put it on the desktop so I know where it is. Hit save. So it saved it. So now we're going to go into the launch visualizer. So I already have it open. So here's the launch visualizer. Oop, my session is expired. So I'm logging back into my account. The last rocket I used was the TTV, but we'll upload a new rocket design. I'm going to browse, and it was on my desktop. There's that Estes Comanche 3 open. I'm going to call it with streamers because I might have this already in my database. And then I'm going to say upload. Okay, it uploaded it. And it's going to, so there's our Comanche 3 sitting on the launch pad. And I'm going to go here to flight event. No, I'm going to go here to my data. And I'm going to select this one that we just ran. So this is the one that we ran in RockSim. And I'm going to load those engines. So I just loaded them. The C5, C6, and the D12. And it also loaded the ejection delay and the ignition delay. So now we need to select the launch site. So the default launch site is in Pueblo, Colorado, but you can choose a launch site. I'll choose this Cloudbusters. And so it will redraw the map of the Cloudbusters launch site. And this is a 3D world. And so right now that's in somebody's driveway or parking lot, but I think there's a field. So here's a nice launch field right here. So we're going to put the launch site right there at that dot. So I just double clicked and it put it right there. I'm going to confirm that launch site because that launch site is at 6,500 feet above sea level. And here's the latitude and the longitude coordinates for it. So now we're going to set the starting state, and it's going to be launched straight up. Since it's launched straight up, I don't care what compass direction because straight up is straight up. Let's select our wind. So the steady wind, I think we had a steady wind of 6 miles an hour. So I'll make that 6 miles an hour, and it's coming out of the west, blowing towards the east. Click OK there. We've already loaded the motors, so then we click on the launch button, which is behind my head here, and then hit simulate. Okay. Andrew Simon says, I designed and built a 3-stage payloader with a stability of greater than 5 with motors. Is this too stable? If so, how do I lower stability? Okay, so here's this 3-stage rocket. And let me bring RockSim back here just a second. Where did it go? Our margin of stability is greater than 7, so this will answer your question as well, is do you want to make this less stable? So what's going to happen is when you launch it, let's go back to the launch visualizer, and we launch it, watch the rocket. Let me look at a fixed view. I want to see the weathercocking cone, because the weathercocking cone, if I display the weathercocking cone, the height of the cone tells me kind of how high the rocket's going to go. So like I said, this is a 3D world, and I know the rocket's going to go way up there, so it's starting out right down there. And if we launch the rocket, you can see this is the trajectory. The rocket's going up, and it's staged. You can see it took off again, still going up, and at this point the rocket is ejected. So I'm going to pause it right there, and I want to show you some things here. So I'm going to spin this around so we can kind of look at it from the side. So we're looking towards the south because the blue down here there's a compass rose and you can't see it. So let me move my screen. So here's the compass rose, and if the blue or the black was pointed up, and I can spin it right here just by clicking and dragging. So at this point, north is at the top of my screen. I'm trying to get it there. It's just real touchy. Okay, so our wind, remember, is coming out of the west, so it's moving from the left side to the right side. And so our launch point was right down here. And I can tell that because if I zoom in far enough, I'll see a launch pad. There's my launch pad right there. And these lines here are the ground path of the various stages. So the booster 2, which is the lower stage, is the yellow. The second booster, which is the middle one, is the blue. And the red one is our sustainer. And so as the rocket took off, it followed that green line right there. And you can see the line, it's kind of sort of going into the wind, which we expect. But now the question is, did it weathercock too much? Is it too stable? Because the like I said before, stability is you can equate it to predictability. So because this is such a stable rocket, I can predict it's going to weathercock into the wind. And so now we're wondering, is it too much? And the launch visualizer gives you some information that makes you to make that decision really quick. And the decision is the color of the apogee point. So all these apogee points, here's the apogee point of the booster 2 stage, here's the apogee point of the booster 1 stage, here's the apogee point of the sustainer. If they're green, they're inside of the cone. So I had that cone here. You can just kind of barely see it. It's an imaginary cone that we use to tell, are we weathercocking too much? And so if it was a red dot, it means it's outside of the cone, and that's what we want to avoid. So this particular flight, even though it's a very highly stable rocket, is okay. So I wouldn't change a thing on this rocket, even though the stability is greater than 7. So what you have to do is, for your particular rocket that you designed, is run your simulations in the launch visualizer, just like what I did here, and look at those points. And it's going to depend on your rocket and your weather conditions. So if the wind is stronger, like right now we had 6 miles an hour blowing across, if it was stronger, if it was like 10 or 12 miles an hour, it's going to weathercock more. And it might change that color of that apogee point. I don't know unless I run the simulation. And we can do that really quick. I'm just going to go to my wind settings right here and change my wind from 6 miles an hour to 12 miles an hour. Hit OK, and then launch it again. Simulate. And it's going to take just a second to do that. It's going to redraw it. So there's my rocket on the pad, and you notice that the time aloft is a little bit shorter, which kind of tells me that the rocket did not either go as high, and you can't see it. Where is it? Where's my rocket? Okay, so there's my weathercocking cone. Let's launch it again. Okay, so the rocket's taking off. It's going up. There's stage 2. I'm going to spin it around so the north is up to the top again. And I'm going to pause it. Let's see what we got. So stage 1 is okay. Stage 2 is okay. Stage 3 is okay. But it's getting really close to the side of that cone. So 12 miles an hour for this rocket is still okay. And so that's the decision that you have to make is, you know, how fast did that take us? You know, that was less than 30 seconds to run that simulation. So that's how you would determine if your rocket is too stable. Now, if you determine it's too stable, what could you do? You have a lot of options. Let me see. One option is we launch straight up, but we can also angle the rocket. Right now, by launching straight up, it's weathercocking into the wind. One of the tricks that you can do is launch it, angle the rocket, not into the wind, because you angle it into the wind, it's going to curve even further, but angle it with the wind. So here in the launch visualizer, I can go to my starting state, and I know my wind is coming out of the west. So to angle it into the wind, I'm going to angle the launch rod to the east, and then angle it a few degrees. So now it's angled into the wind. You know, you can see over here is my picture. This arrow here shows my wind direction. And here's the compass on the ground. You can see I'm angled with the wind, not into the wind. And then so when we run this simulation, one of the things that's going to happen is it's probably going to weathercock less, because it is going to weathercock, but it may go higher. I don't know until I actually see it. Okay, so there's my rocket. Let me swing it around to the north. Let me first, yeah, let me zoom out. So there's the rocket sitting on the pad. Okay, I'm trying to get my cone inside so I can get a perspective. So now the time went up a little bit. Okay, so it did go downrange a little bit. That motor, see, look at that. It's got a nice little S curve to it. It's not as arced into the wind as before. See that? Now it's like almost, you know, pretty close to being in the center of the cone, which is really good. And so that is something you can do without changing the rocket at all. Let me close that. And if you go to the summary here, we can see that by angling it with the wind, we actually went higher than aiming straight up. Here it was 2,200 feet, almost 23. Here is 2450, 51 feet. The other thing you can do in RockSim is you can, to make the rocket less stable. How do you make a rocket less stable? Well, the one thing is change the size of your fins. The smaller the fins, the more that center of pressure point. Here's the center of pressure point, is this circle right here. If the fins are smaller, that center of pressure is going to move forward, even though the center of gravity might not move forward too much. It will move forward a little bit because the size of the fins is smaller, so they weigh less. So the back end is lighter, so the center of gravity is going to move forward. But the center of pressure is really going to move forward because that is really affected by the size of the fins. Personally, I wouldn't change a thing. If your rocket is stable and it works okay, don't change it just to make it weathercock less. Change the way you fly the rocket. You know, like I said, you can angle it with the wind, or another big thing you can do is just choose to not fly that day if the wind is too strong. You don't have to fly it, just pick a different rocket. Just wait until the conditions are right. You know, at the beginning of this, we talked about the So Long rocket, which you can't see, and I said, maybe I'll fly it tomorrow if the conditions are right. You know, that's a decision that you do control, is when you fly it. So, you know, make a good decision. Let me go back to the comments here. I've been talking a long time. Not talking a lot about a lot of subjects, but we talked a lot about really good topics. Terry Wheelock says, how do we design grid fins in RockSim? And the answer, Terry, is you can't. Our fins are limited to what we have here. We have regular trapezoid or elliptical fins. We have custom fins like these right here, which have a shape other than trapezoid or elliptical. Then we have ringtails, which are rings around the outside of the rocket. And then we have tube fins. But there is no grid fin button. Grid fins are typically used on supersonic rockets. They're not really very effective on subsonic rockets because there's just not a lot of air flowing through them. You know, SpaceX uses them. The Russians use them on some of their rockets. They're not typically used in model rocketry. We did have a kit one time that had them, but in order to make them work, you had to put a lot of nose weight in them. David Porter asks, in the RockSim under the file menu, the printer setup menu does not do anything. Is there something wrong? So what he's saying is if you go here to printer setup, yeah, it doesn't work. If you want to print, go to this button right here. Print from this menu right here. And also be aware, you have to also check the additional settings, because sometimes this little button right here is checked that says print to a PDF. And if you print to a PDF, it's never going to reach your printer. So make sure it's unchecked before you start hitting print. So then if you wanted to print, you'd either pick, okay, I want to print simulation information, which we saw up here, or we can print the rocket information like parts lists. You know, if I hit parts list and clicked OK, it would try to print. It's going to bring up a printer dialog. So here's the printer dialog where you can select which printer you want, how many copies, the range. On the Macintosh, I can also choose to print to a PDF from here. On Windows, that doesn't work. So if you want to print to a PDF on Windows, make sure that you print to PDF here. Click OK. I am printing I don't want to print a parts. I want to print templates for like a custom fin. Click OK, and this should print to a PDF, even though it says it's going to print to Michelle's office. If I hit print, it should print to a PDF. Okay, so it's asking me where it's saving it, and I think I want to put it on the desktop. Hit open. And I think it printed, or no, I think it doesn't save. It doesn't save them there. If I can open up my browser here, did I put it on the desktop? Yep, it sure did. There it is. So it printed it to a PDF, and if I open it, I can from here I can also print it right to a regular printer, but that's a full-size template of that particular fin. The problem is I don't know which fin that is. If it's because all my fins in this rocket are named custom fin. Not a good idea. You know, ideally what you want to do is, like, you know, find the stage like this fin right here, and then you can double click on, oops, I opened the wrong thing. If I double click on the fin, it should open it up, and I could say, you know, sustainer custom fin. And so now when I go to the print menu, here it is, right here, sustainer custom fin. So the fin that I printed was one of the other ones. So anyway, so that answers that question about the printer setup. Rick DeFossa says, I got my level 1 a couple weeks ago with the Zephyr. It was a great flight. Great, Rick. I'm happy to hear you were successful. I think you sent me some photos. They're probably still in my inbox. Chris's Rocketry and More, he says, I really want to get my level 1, but I just learned about the ATF permit. That's no fun. Well, Chris, when you fly a high power rocket, yes, there is a permit, but it's not an ATF permit. It's a Federal Aviation Administration permit, because the rocket, the FAA in the United States controls the airspace above the ground. So anything that goes up and above the ground is technically in the jurisdiction of the FAA, which includes buildings, which is why tall buildings have lights on them so that aircraft can see them. It includes kites, you know, helium balloons, hot air balloons, drones, and model rockets. So the FAA wants to know if you're flying a model rocket that weighs more than 1 pound. And if it gets over 3 pounds or 1,500 grams, you have to get a permit to fly it. Basically, it's called a waiver. So that you get a waiver from the FAA to fly your rocket, but you don't need any ATF permits. We won that lawsuit in the United States probably a decade ago. Model rocket propellant is not an explosive, so you don't need any permit to fly them. But you do need FAA waivers. And so if you're getting your level 1, the other criteria for a level 1 is you need a witness. And your witness either has to be a NAR or EEE certified flyer. And they know all the rules, and they know that you're going to need an FAA waiver. And typically what you do is you go to the club to fly your rocket, because that's where your witness is going to be, and the club has the waiver. So if you're flying with a club, all you do is show up with your rocket, show up with your motor, find your witness, and go get your level 1. Most clubs, you don't even have to notify them. It is nice to notify them ahead of time saying, I'm coming to your launch. Can I get certified? Will you have a witness there that can help me? Do you have your FAA waiver? And most clubs have standing waivers with the FAA. Of all the government organizations, the FAA has been really nice to rocket enthusiasts, because they're rocket enthusiasts too. So they like to fly rockets themselves, so they helped guide the laws through Congress to allow for rocketry. And so they made it as easy as they can for clubs to get those waivers. So don't let that get in the way of getting your level 1 certification. Just get your rocket, get a Zephyr. I recommend a Zephyr. Get that H100, or, you know, you saw the list. You can run a simulation really quick to get your recommended motors. There's a lot of motors that will work. Pick one that's going to give you a fairly low altitude so you can get it back. Fly your rocket and get your level 1. You know, ask Rick how easy it was for Rick to get his level 1. Let's see, what other questions we got here? There's a lot of comments. Johan said he's made a gap staging rocket that he made from stuff lying around. That's cool. He says for me to look at it, and I'd look at it if you'll send me a picture. Carlos K says, any expert hints on the best way to put, oh, we already answered that question. How to put streamers in a Comanche 3. So you can do it in RockSim, that's easy. But now how do you actually put it into a rocket, into a 2-stage rocket with direct staging? Now that's a trick. And I'm trying to think where I have information on that. And I think it's in the book Model Rocket Design and Construction. Model Rocket Design and Construction. So if you go to our website and just type in MRDC, which stands for Model Rocket Design and Construction, you can click on that link and it will take you to the book, and you can buy the book. And in the book, there will be a section on staging. And I think I have some tips in there on how to do putting a streamer in that bottom stage. And to be honest with you, you're not going to be putting the streamer in the bottom stage. You're going to put it in the top stage. And you're going to have your shock cord run from the bottom to the top stage, and you're going to yank the streamer out of the stage on top of it. That's really the only way to get a streamer out. So you might have to put a pod on the outside of your rocket. But if you're interested, Model Rocket Design and Construction, it's a great book. It's like, I think it's like well over 200 pages long. It's huge. David Porter says, thanks Tim for the clarification. It would be cool to print the parts list in a CSV or a TXT format suitable to upload to a spreadsheet. Yeah. Parts list. Can we do that? Print. I don't want to print templates. I want to print just a parts list. The thing, when it prints a parts list, it prints all the dimensional information about the part in case you need to build it yourself. So I'm printing a parts list, and I'm gonna put it on the desktop again. Click open, and it should have saved it on the desktop. Comanche 3 parts list. So here is the parts list. Like I said, it's got all the dimensional information on all the parts. You know, you have your nose cone and your body tube, and it's not, parts lists are not easy to put into a table format, except for, you know, name and name. Even quantity could be hard. You know, like having 2 tubes the same length, it would be hard. This has, you know, the name of the part, its part number, the material, the outside dimension, the inside dimension, the length, the center of gravity location, and, you know, other engineering data about that part. So, yeah, it's hard. It's an idea. I'll have to think about it. Josh Keating asks, if my level 1 is greater than 3 pounds, that's still covered under the club's FAA waiver? And the answer is yes, it is. As long as a waiver means you're going to violate the rules, And they don't care how you violate them. They just want to know where you're launching and how high you're going. And they may want to know how heavy it is, but when they give you a waiver, they're giving you a column of air above the ground. And as long as your rocket stays in that column, you're okay, because what the FAA is going to do is they're going to direct airplanes around your column, keep them out of your airspace. They've given you a waiver that says that's your airspace for that specific time. James says, Chris, a person used to obtain an explosive permit. However, as Tim stated, this is no longer a requirement. Thank you, James, for doing that. You probably answered it before I did. And Rick also answered, yes, the club waiver will cover you. Rick also recommends the Zephyr, and I think that's it, all the questions for today. And we are past 3 o'clock, so I think we're going to be done for the day. I've got to get ready for a launch tomorrow. I want to fly this. I want to fly the Estes So Long, and I have some other rockets. We're getting ready to go to the World Space Modeling Championships. We're leaving next Friday. That's why I'm not going to be here, because I'm going to be driving to Texas. Michelle will be here, but we're going to be doing some last-minute test flying, trying to get ready for that contest. I mean, this is the World Championships, and we got to be ready. And my daughter is the one that's actually flying the rockets. And, you know, the more things that can go wrong, we want to find them out now rather than during the contest, because if you find them out during the contest, you're disqualified. And we always find out things that can go wrong. So even though my launches may not be perfect, it's a step towards perfection. All right, so Stirk3 says, when will the launch visualizer be in stock? And the answer to that, Stirk3, is it's already available. We don't sell it on the Apogee website. You have to go to the launch visualizer. Let me go back to that. You just go to RockSim.com. So you open up a browser, you go to RockSim.com. And that's where you will pay for the launch visualizer. It's loading right now. So when I say pay, there's 3 levels of membership. There's a free membership, which, you know, when you first start it up, after it will load, you can run simulations. But the caveat is your simulations stop at Apogee, and you're limited to motors that are up to a D engine. And then the second level of membership is also free, but it requires payment of your email address, because when in the second level of membership, we're going to give you disk storage space on our servers for your rockets. So like I did, I had that Comanche 3, I uploaded it to the cloud into my storage space. And so we need to have your storage space designated for your rockets. So that's why we need a login for you. That's why we need your email address. We're not going to spam you, you know, but we do need that to be able to provide the extra levels of capability. So once you have a free membership with a login, you can fly up to a G motor, so you can do G, you know, D through G, and you can also upload your own designs. And so if you want to fly past Apogee and see where your rocket comes down, at that point you have to get a paid membership, and we charge $3, just $3 a month for that feature. So it's not going to break the bank, and you can do hundreds of launches on $3 a month. There's a limit to the number. We base it on points, And so the points are how many Newton seconds of power you're flying. So if a low power motor doesn't use a lot of points, but a high power motor is going to use a lot more points because the rocket goes higher, and that takes more computational effort. Because it takes more computational effort, we got to charge a little bit more for it. So we base the points on the Newton seconds that you're using of your rocket motors. So, you know, a little A motor has 2.5 newtons, so you'd use up 3 points because it rounds up to 3. A B motor will take 5 points. A C motor will take 10. And I think you start out with like, I think on the free plan is 4,000 points. So you can do hundreds of flights. And if you run out of points, you can top off the tank with a little bit more, you know, just a little bit more money. I'm not making any money on the launch visualizer. I'm losing money on the launch visualizer. It's a great program. Anyway, that answers that. That was a great question. I'm glad I stuck around for it. I'm trying to close out that. Okay, so Sturk says good luck at the competition. So thank you. I just hope I can get down there safely because it's a long drive to Texas, and my daughter's going to do the flying. So hopefully she has a good competition. I win either way because I enjoyed the process of getting ready. I enjoyed the time spending with my daughter, and we're going to go out fly again tomorrow. So I get those points, and then you know, I learned a lot. So it's going to be good, unless something really, really bad happens. But hopefully that doesn't happen. So we will be back. Michelle will be back next week. Have your questions ready. She can answer them for you, like she did last week. She's going to be here for 2 weeks in a row because that second week. So next Friday is my travel day, and then the following week is actually the competition. But then the third week, I'll be back. So we got to end here. So in 3, 2, no, I got to count this down. In 5, 4, 3, 2, 1, go out and launch something.